Hi everyone, and welcome to my talk. My name is Biton, and I'm an offensive security engineer and researcher working at Signia Consulting. I have over 5 years of experience within the cybersecurity industry, focusing on enterprise security. I'm originally from Israel, but currently based in Singapore. And today I want to talk with you about red team and adversary simulation challenges and show you how you can adapt CI/CD concepts in order to automate tasks that are related to your weaponization phase. Let's dive in. So first, let me give you some context. We have to admit it, red and purple teaming became harder. Throughout the past years, red teamers are struggling with challenges since organizations have lifted up their detection capabilities and also integrated advanced security solutions. This caused the execution of even basic tasks to get complicated. Organizations have also a variety of products and vendors incorporated within their environments. This makes techniques that worked in one organization to fail or get detected on another. Logging and monitoring capabilities were also enhanced. We are recorded 24/7 by the Big Brother SIEM and its SOC siblings, so avoid triggering alerts during an operation became a challenge by itself. To handle the situation, adversaries spend even more time on the weaponization phase. And this is done prior and during the operation. Many times these tasks are repetitive and sometimes they fail due to technical issues that we all have experienced before. Let me ask you a question. How many times have you weaponized the same tool? Or how many times you helped a colleague to use a technique that you found or used? Speaking about colleagues, while working with a growing team that are divided across multiple engagements, we realized that new challenges were added. These challenges include working from home due to the COVID era, back-to-back engagements, and new developments that team members created got lost as soon as they finished their engagements. Because of that, we understood that we want to have a better platform to collaborate on. In my opinion, we can enable base standard and equal capabilities using these kind of platforms. Now, whenever we do develop or discover a new capability, we have to somehow store it, right? There are many documentations and methodologies out there, and every day a new exploit, technique, or tool are released. I'm pretty sure that you're experiencing the print nightmare buzz in your social media networks currently. So sometimes it's hard to follow and incorporate these methodologies, techniques, and tools into your methodologies and day-to-day jobs. Security teams are also sharing thoughts during whole conversations or coffee breaks or mingling in conferences, but memorizing and storing this entire content in an efficient way became complicated. So until Elon will provide us his Neuralink, we have to find a solution. We understood that we want to import more automation into our engagements, as we want to reduce the time on repetitive tasks or tasks we are not interested in doing again. We know that the community already adopted the CI/CD concepts to automate tasks that are related to offensive tools weaponization. Offensive CI/CD pipelines have been around for a couple of years, with the goal of helping red teams to automate their tasks. I'm not going to talk in detail about CI/CD in general, but we are going to dive into the advantages of having it and using it for offensive needs. I truly believe that we cannot automate the entire red team operation, as we need to bring our own expertise, knowledge, and way of thinking. We want to have a mind behind the operation who can take decisions in real time and according to the feedback he receives from the network and the environment he is attacking. Then we will be able to put more focus on bypassing new barriers which we never tackled before. We started exploring the CI/CD area and performed a research that ended up with a pain that we really wanted to solve. This pain pushed us to design and develop our own offensive pipeline framework. This is done while focusing the needs of our growing adversarial team. So such needs included simplicity. As being part of a growing team, we wanted to onboard new members to use that concept easily, and also make it easier for us to do the migration. There is also a need for modularity. The framework must allow the developed techniques to be packaged individually, so we can mix between them when assembling pipelines that weaponize different tools. We also wanted that the framework will be able to maintain itself, so we don't add overhead on top of our tasks. We're also looking for a system that anyone can contribute to, because we're a big team. We can actually use that. So we want the efforts to be gained from each and every team member, instead of only one researcher maintaining and enriching it. Sorry. We wanted also the environments to be the environment's infrastructure to be self-managed. As the sources and the tools that we are using considered malicious, right? And having this CI/CD on a SaaS solution can make our tools get analyzed or blocked in the future. So SaaS solutions can create obstacles with that throughout the way, and we will discuss about that later. There is also a need for a demand, because while perform red teams, sometimes you're in a need for a specific tool. I am pretty sure that you have the default set of tools that you tend to use in red teams, but I'm also pretty sure that you tend to find or use a new tool every red team to get to something, finish a task that jumped out of everything you found. Because we also distribute the tools to each and every engagement, we don't want the tools to have the same signature. So anyone needs to get a different tool, we can share between them. After considering these all needs, we ended up choosing GitLab as the core of our framework. If we are looking at its high-level description, we may predict that it can answer our needs. Let me explain you why. We researched a variety of frameworks such as Jenkins, Circle CI, GitHub Actions, and AppVeo. And AppVeo served us for the past year, where we learned the power of having CI/CD concepts within your offensive security needs. These tools did not come up with our needs. Even GitLab was not perfect. We actually started going over its source code when we saw a possible constraint. High level is gibberish. Let's discuss the technical aspects of GitLab. So GitLab started off being a code repository and version control, allowing you to store your great tools and manage them. GitLab also provides a useful API which allows you to automate anything that you can do manually. It comes together with a detailed documentation that saves you some time when you try to figure out how to approach a call. A must-have feature, of course, is the GitLab CI/CD. providing you with the ability to create pipeline jobs, which I will refer as recipes, in a simple and organized manner through its YAML format files. The CI/CD also offers multiple integrations to different systems where you can execute your job recipes. For example, as part of the CI, you can use Kubernetes to execute your jobs on specific container images. You can do it on Docker, and you can do it on a single server, whether Linux or Windows. It's up to you. Jobs can also be executed on specified conditions. For example, because GitLab is a source control, once you push a new commit to one of the branches, it can trigger a pipeline to run on the changes you've made. You can also trigger the pipeline from the API, or you can also trigger the pipeline after another pipeline ended successfully or unsuccessfully. The multi-pipeline support allows to trigger several pipelines through executing only one. If you think about that, sometimes you need several types of tools or several tools to do the same task, because we are not always trusting one tool when we do our simulations. And having a single click to weaponize them can benefit a lot for you. I'm pretty sure that also this is just the tip of the iceberg. GitLab is a big system, and I'm sure that you will find additional features to use in the future. Let's see an example of an offensive pipeline recipe in motion. The pipeline starts off cloning the code from the source control. In this example, we use Rubius, a C# tool. Then it gets built using a predefined job, a recipe, that locates the solution file and uses msbuild to compile it. The binary artifact then passes through the pipeline to the next job that executes confuser EX on it. And this is in order to obfuscate it and modify signatures that may trigger an alert or make the file event not being executed on the targeted environment, or even deleted. The confused binary or the shellcode that you will create throughout the way goes to the next job, where it gets wrapped by .NET assembly so we can actually execute it from a PowerShell console. And eventually, artifacts are all together deployed to your favorite bucket, AWS, GCP, Azure storage, and as well as to your Pandrop server, allowing the adversary simulator, the operator, to pick from which hosting he wishes to download and execute the tool. Another PowerShell example can go with invoke domain password spray, where it doesn't need to get built, but aggregated from few PowerShell files. This is another job you can define. Then the combined PowerShell script passes through to the next stage, where it gets obfuscated using Chimera. Chimera is an obfuscation script designed to basically bypass AMSI and antivirus solutions when you try to execute PowerShell scripts. The obfuscated script then goes directly to the last job in the pipeline and gets deployed to the Pandrop hosting server. In the same way, we may add additional sources of different tools and define their pipelines and recipes with jobs that we already developed. And this is where the modularity plays its significant role. For dessert, we can use the pipeline triggering options or GitLab API to trigger multiple pipelines based on different grouping. And this is enable you to create and weaponize tools based on different kind of needs, as I mentioned before. Finally, it enables us to weaponize tens and hundreds of tools in minutes. We took this type of example and started building an infrastructure to support the operation. We started off, of course, with a GitLab server, GitLab instance that comes with the built-in CI/CD, and also we chose to execute our jobs to build and execute and obfuscate and all the things that we're doing on a Kubernetes cluster. And this Kubernetes cluster came with a Linux node pool, and we also made a Windows node pool, since we believe that sometimes we will be in a need to create the tasks on a Windows-related container image. Sometimes you will need to build .NET or C++ for Windows, or Go, or test on Windows servers or workstations. So I know that because the targeted environment is Windows, so testing and having the building process on Windows can be very beneficial. Now, the Kubernetes cluster has to somehow communicate with the GitLab instance. And for that, GitLab created something called GitLab Runner. This is a Helm deployment that you can provide to your Kubernetes, and it's kind of proxying your jobs from the pipelines into your Kubernetes cluster, translating them into pods that contain two different containers, one that you specify to actually do the job that you intended to do, and another one with the helper container that does the Git cloning and artifact collection from the job. Now, currently GitLab is not supporting building on using pods, running jobs on a Windows-related images, and we created a workaround for that with another Windows runner that basically can work with Windows-related images that contain the PowerShell core program and libraries. This Kubernetes cluster is also accessible to a container registry where you can store your customized containers that you use for building, or let's say the one with msbuild or the one with the obfuscation that contain the confuser and all its dependencies. You can just pull it and execute it right away on the binary or tool you want to obfuscate. Now, after having some tests with this kind of infrastructure, we decided to go with it into Google Cloud. And we use these Google Cloud services together with the Google Cloud Storage to host some utilities we needed during the pipeline. Also, we added a firewall rule for us to operate the whole system. And by the way, this is the single point you have to operate and maintain the GitLab instance itself. Everything was sitting on a single GCP project where you can manage everything in one place. And eventually the GitLab server, the GitLab instance, will be able to pull Git repositories from remote paths. Then you will be able to create for them kind of recipes and build and weaponize them. And after having this infrastructure and the framework in the GCP, we built a Terraform script that can enable you to deploy the same environment into your cloud subscription. Now, as part of this script, we created as part of this framework, and this script is part of, we created a framework named scalabs. And in a high level, this framework can empower red teams by enabling them to put more focus on what they need to do instead of how to do it. The how will be predefined by them, by their researchers, by the operators, but the concept is to define it only once and focus on what is the next step, what is the next task that you need to do. And this is done with recipes with YAML format files that are that in a repository that we created, together with the infrastructure that you will be able to deploy into your GCP account. All you need basically to download and deploy the same environment is a GCP subscription and a web browser. You can refer to the project's repository and follow the instructions. I want also to share with you the difficulties that almost killed the infrastructure technologies we chose. So the first one is a lack of support by GitLab to actually use Windows-based nodes to build and run our pods on. So this is an open issue. I'm pretty sure that it will be soon solved, and it seems to be on the next version. But we had back in the days when we created this framework, we found a workaround for that. And this is because GitLab allows you to execute pods and jobs on Linux-related nodes, which also contain PowerShell core. And the PowerShell core we used to actually build Windows containers, and found that if we import PowerShell core, we install PowerShell core into the container image of Windows, and we can actually use it and work around over this lack of support. And GitLab works in that way that each job creates a pod in your Kubernetes cluster that contains two different containers. One helper that downloads, perform the Git cloning and send out the artifact and do more things for preparing the environment, and the container that you specify for building or creating the job you need. And they are working together. So we had also to install the PWSH into the helper container and change it through our GitLab runner that I showed before in the architecture slide. Now, the next thing that this lack of support prevented us from using is the nice way that GitLab allows us to collect the artifacts from a job. Imagine that you are now building your offensive tool using C# on a Windows container, and you want to collect the executable, send it to the job artifact, so the next job in the pipeline will be able to pick that. GitLab created this way in order to do that, and this is a very nice and clean way, but because of the lack of support in Windows, it doesn't succeed in finding the GitLab runner helper, because it attempts to do that in a Linux structure. So we find a workaround when we take the GitLab runner helper binary and use the artifacts uploader functionality together with environment variables that already there in the job variables. We didn't need to create new variables for that, and just upload it to the job artifacts, and then we actually can use a different kind of container, different kind of job to pick it up. Now, the second thing that almost killed us is the Google Kubernetes Engine Windows images. It offers only two different Windows images, and they both come with pre-installed Windows Defender. Now imagine that you're building a malicious tool on inside a container on a Windows related node, and the Defender deletes your compiled binary on the second you're building it. It also provides this nice log to your screen, but we also we also succeed in workaround over that one. So we attached the Windows pool with a startup script that each time a node is provisioned by the Kubernetes cluster, it runs it executing the startup script, PowerShell startup script, that basically disable the Windows Defender. If you want, you can also add another PowerShell script into that script in order to modify your hosting node server. Now it's the demo time. Let's start. So we start off referring to the scalabs project, where we can find basically all the deployment scripts based on Terraform. We can find the instructions on how to clone it and deploy it into our GCP. As you can see, I have only one instance in my GCP, is a Pondrop server for this demo. This one, as you can see. Now it's empty, but we will fill it up. The Kubernetes engine is also empty. There are container registries here that are related to Windows. I added them beforehand in order to be able to use them during the pipeline. The storage contained the container registry as a storage type because this is the way Google are using to store containers. It's kind of reflected out of there. And also the secrets manager, where we will use to store secrets related to our environment, such as the GitLab password, API keys, certificates and other stuff. Oops. Let's get back to where we've been. Okay, so we're waiting to the Cloud Shell to load, and now we will clone the scalabs repository, and we now have to edit the config Terraform variables. This is according to our needs. Let's see. So we have 3 different required parameters. This is the project ID, the full project ID from your GCP project. In this case, scalabs demo. And also an operator IP, so we will open the rule in the firewall for you to be able to log in into your GitLab instance. Let me take the external IP, and also let's give it a name, info name, we'll call it demo1. Save the file. And let's initialize the Terraform. It will install all the necessary libraries and modules. And then we will be able to apply the resources into this project. See that we're actually mentioning the config tfvars that we just created. Okay, so now it calculates the resources, and also we have to authorize it to use this project. There are 50 resources in total to be added. Hitting yes, and resources are starting to get deployed. We'll skip that. Don't want you to wait. It takes around 10 to 15 minutes. And we have all the resources completed and deployed successfully. As you can see, we have the GitLab external IP, and we will be able to reach it because we just provided our external IP address for it. Now the root password of this GitLab instance is stored in a designated secret that we created. You can see the name of the secret within the next variable. Demo GitLab root password. Let's refresh the secret manager because there are additions. And we can extract the root password. Sign in. Great. As you can see, we have the monitoring, which is a default project coming with GitLab, and the scalabs recipes, which was imported automatically using the deployment. The scalabs recipes contain all the YAMLs and tools that are the recipes that are required to do some jobs that you need to weaponize your tool. Of course, that this is just an example jobs that you can learn from. You will have to extend it a lot and test it, but there is a lot of value already in there. Let's see some of the features that the scalabs recipes pipeline offers. So the first thing is deployment initialization. So once we deployed everything to our GCP, we really want to import additional tools to our environment, and also we want to have additional containers to use through our jobs. So we have the health check as well to check that we can actually execute things on Linux and on Windows as well. We have the feature check. We want to check that our API key function and is authorized to do the stuff we need. And now I want to show you the jobs and what each of them does. I really like the web ID to explore the files, as well as to commit new changes when they are not so managed, just to kind of save here. The GitLab CI is the master YAML for these scalabs recipes, and now we saw that it executes these 4 stages that are coming from jobs within a referenced YAML files. Let's see the OS trigger YAML file. So we have 2 different jobs here, both at the health check stage. They are running, one of them is running on the Linux related server, and the second one on Windows with designated Windows and Linux related images. They just check that they can schedule on Windows and Linux respectively. The second thing is the variable check. We want to check that we have API access to the GitLab, so we can use other functionalities by initializing the whole environment and maintaining it. So the third job is related to building containers. Let's see what this job does. It uses a technology by Google named Kaniko, and it basically builds all containers. As you can see here, we didn't reach that yet, but it builds all containers that are listed as Docker files under CI maintain Docker files Linux. You can see all the different Docker files we have here. They all will be pushed to our container registry in addition to the containers that you've seen there before. So the last stage that we are using here is the tools imported. This is a very powerful feature that basically allows you to import new tools to the GitLab instance by specifying them as a code. You can see that it goes to toolsindex.json file and compares its contents with the existing projects within the instance, and it uses the API key to do so. Eventually, it imports the new projects that were not existed in the instance. We'll have an example of that as well. If we're looking at the tools index, we can see all the tools that will be imported once the job that we are currently running will be finished. This is an array of objects containing the name, the Git path where we want to import, the visibility level, who we want to have access to, and the CI config path, where we actually have the recipe to weaponize that tool. And in that case, it's here, right here, the Rubius CI.yaml, where we set some variables, include and reference additional YAML files, and pass it through different 3 stages of building, obfuscating, and deploying. If we're taking a look at the building stage, it's a job that builds sharp tools. Now, this job is running on a container that we created for it, and you can see the container here in the registry. We're actually pulling it from there. Sorry. And we're actually running this on this container on a Kubernetes, through the Kubernetes runner. We're restoring the packages that are required and building with the release configuration from the solution path that we specified during the recipe. And every job gets the repository into its workspace every time it starts. Eventually, we're uploading the artifact, the compiled Rubius, into the job artifact, where we can use it for the next pipeline, for example, for the confuser to run the obfuscation techniques over it. Let's see the obfuscation part under the CI obfuscations and confuser EX. So we have another job that we actually fetching the previous artifact. This is the workaround we spoke about. We're fetching the artifact from the previous job. We're running everything on a container that's designated to do so. It's another container stored at our container registry, containing all the necessary dependencies for confuser. And actually from line 23, we are starting the operation of obfuscating our tool with very specific parameters, I have said, but this can be also configurable or forwarded from a variable, environment variable that you can use. Eventually, we're copying the obfuscated artifact and upload it to the job artifact, so the next job in the pipeline will be able to pick it. So the next job is related to deploying. So here is deploying the file into our Pandrop server. It will be under CI deployers in that structure. And we can see that basically it requires the Pandrop URL and the write key. It runs on a different operating system and different container. Notice that we are using this, through the same pipeline, we are changing operating systems and containers. And eventually it gets the file from the previous job and deploy it through the Pandrop URL and write key. As we will be able to see it over here. But we must provide it the URL and write key in order for it to find the relevant server to upload to and succeed. Let's execute the Rubius pipeline. We also can see that the initialization pipeline has proceeded and finished with the health check, and now it's on the feature check. The check variable was failed, but we will check right now why. As you can see, because we used a container that does not include CURL binary, it couldn't use it, so it found an error and failed, stopped the job. And we will be able to change that by not using CURL, using something else, or using a container image that contains CURL. We can also install the CURL before doing the operation. So once all the jobs and stages are completed, we can take a look at the build container job. And this job was actually took all the Docker files that you've seen and added them to here. Let's refresh to see it. As you can see, 3 different container images that built out of the Docker files we listed under our Linux. The last job was the tools importer, which should add the projects into here. If we refresh it, we can see all the additional projects that just added to our GitLab instance. This is a very powerful feature. Because we just added Rubius, we didn't have it before. Now we can actually execute its pipeline. The recipe already been to the scalabs recipes, and the Rubius is pointing at it, so he knows what to do. You will be able to see that it will use the build, confuser, obfuscate, and deploy stages with the same thing we mentioned before. At this time, it will not be deployed to Pandrop because we didn't supply the Pandrop URL and write key for it to locate and access it. So the deploy Pandrop job will be failed. Now we can see what happens behind the scenes when we are creating a job. We have the Google Kubernetes engine nodes here. And we also have the pods and the deployments that are related to this cluster. The first one is the Linux GitLab runner, and the third one is the Windows that we spoke about, proxying our jobs. The second one is the actual build job that we are seeing here. It created a randomized character pod that pulled the container that we specified together with the helper container that it needs to get in order to finish the job successfully. You can see the events until the container are starting. Everything else that happens can be seen at the pods log. From here we can see also what happens inside the container. And we will be able to see that Rubius is actually get built using MS build, and the compiled artifact is collected and uploaded to our job artifacts. This is the area where we upload it, and it's available on the right side, so we can download or browse it to kind of check ourselves, model things. We don't must to deploy it somewhere else in order to access the file. We just need that. This is in case you're trying to operate a rating. So the Confuser EX part will be taking the compiled Rubius and also create his job to obfuscate it and give us the output. Takes the container from the same place we've seen, and now we can see that it's still pulling the container from our container registry. So the job was done, and we can take a look on the results. We can see that it was obfuscated using the confuser with our predefined job, and the Rubius X was obfuscated, and the obfuscated version was uploaded to the job artifact, where we can see on the right side. The pipeline was considered failed because not all jobs were succeeded to pass. And this is because the deploy prundrop job was failed. Now let's say we want to import another tool. We can add another object into that array and specify and build its recipe. Let's copy an example. We will take the sharp block tool for this example, copy its git path, don't forget to change the name. We'll keep the visibility internal, and we have to point it at some recipe and YAML that will instruct it how to build itself. Now, because this file does not exist, we'll have to create it by our own. So it will be under CI tools controllers, as any tool here. And we'll take an example from how we did with Rubius, but this time we will use only the building stage and job. We'll have also to clear the variables and switch them with the related tools variables. Clean also the build and the obfuscate and deploy parts. Keeping only building the tool to see if we can do that. We have to specify the solution for the next job, for the build job to find it. And since we want to collect the artifact, we will need to specify the executable file name, and we need to specify the correct path. We'll try to extract it from the csproj file. Under the release configuration, you can see that it's under bin release. Specify it. You can flip to /, it's not a problem. Now we have to commit the changes that we've made into this repository. So the sharp block tool will be able to get imported and to read its YAML recipe. Seems that other things were changed. Nothing here, just a new line. Let's see, Rubius as well. Again, new line. Can delete it. Still here. Never mind. Let's commit and see. You can see that there is a new tool imported to the tools index. and a new file. Committing the changes. Great. As you can see, a pipeline was already triggered by this commit to import the tool that we've just added, and this pipeline is automatically created using the conditions I mentioned before. Now what it does, it takes, as I said, it takes the tools index and it sees that there is a missing tool in the instance, and it will import it in few seconds. You can see also a pod that actually assigned for that, containing a pod that contains two containers, this time Linux related containers, Ubuntu and the GitLab runner helper. And we can see that it succeeded and another tool was imported to our project list. Let's go to the main page. We'll be able to see sharp-lock right away. And even execute its pipeline. You can see that it contains the build job as we defined it to do. And now it will attempt to build it using the job that we already predefined and use the same job for Rubius and other C# tools. You see that the job has succeeded. Now, let's move on. Another cool thing within the scalabs recipes pipeline is that you can basically create Docker container images from a Docker file. And this goes with coding your infrastructure, coding everything you need, and also the jobs that you will need to execute during your pipelines. So before that, we will see the multi-pipeline support, and we can see that there is a trigger for 3 different tools: the PowerUp, the Rubius, and the Godi. Now, these tools these jobs will trigger the related repository tool by triggering the scalabs recipes pipeline and providing the relevant variable to execute them. If we run the pipeline of scalabs recipes and specify the CI multi-trigger variable with the desired value that contained in the different trigger jobs, we can actually make them trigger the relevant repositories. If you want to deploy them to our Pundrop server, we have to specify its URL and its write key. We can do that right now. And the key. This is a customized Pundrop available in my GitHub. Hitting run pipeline. And we can see 3 different downstream pipelines that will trigger and to make our and weaponize our related tools. Let's skip this. And before we show that the related recipes were triggered with their respective stages. Don't want you to wait for that time. Okay, once all are finished and we can see that also the deploy pun drop was succeeded, everything is green, we'll be able to see that these files, these binaries, were added to here. You can see the three different tools that we just triggered their pipelines submitted their binaries right to our pun drop hosting server. Getting back to the scalabs repository pipeline, we saw that the container builder support that builds these three different Docker files. And let's say we want to build another Docker file. So what we do is adding a new file, let's say chimera-2.docker file. And for this example, we will just copy the content of the other Docker file, other Chimera Docker file, but we will change the base image for the Docker file. Can change it to Ubuntu 20 or maybe Ubuntu 20, or maybe Ubuntu latest. Now we have to commit this Docker file. We can see it added here. And we can run actually the pipeline of the scalabs recipes and use another variable called dockerfile build Linux, where you have to specify the prefix of your Docker file name that is existing other dockerfile/linux. We specified chimera-2, and the build Linux container was triggered within our pipeline, and eventually we'll be able to see it in our container registry. Refresh it, and a new container image was added. So this is all for this demo. I hope you enjoyed. This is a very nice example you can actually learn from and develop and design new capabilities for yourself, for your team, and also contribute back to the scalabs recipes repository hosted in our GitHub. Let's move on. A few words about the cloud costs. We can divide them to idle time and per job time, because when we are actually running pipelines, we are provisioning node images that we are running pods and containers over them, but they are disposing fast right after 5 to 10 minutes right after you finish your job pipelines. And on the idle side, you have a GitLab instance and a Linux node that are actively always on to serve you when you need them, when you need the framework, and they cost most of the credit. So unless you don't actually plan to supply the weaponized tool to the whole security community, you will end up around $100 by using this framework and deployment. You can also turn off the GitLab instance or some of the cluster nodes, but it it's up to you. Additional thoughts that came up to my mind during creating the framework, the design, and this presentation is that this is can be a community-driven framework. I mean, because we have the scalabs recipes repository that is hosted in GitHub, anyone can deploy the same infrastructure to himself, designing recipes, designing new techniques, modules, and contribute back to the community in the same way that people do today with CobbleStrike aggressor scripts. Also, we will be able to see that many tasks that you tend to do in adversary simulations and red team now are faster. And this will come up with a new need to process this data, because you will used to do to run a tool and look at the results of the previous one, trying to figure out what you're going to do, what are your next steps. Also, maybe you thought about using C2, that it does your tasks in an effective way, very fast. We didn't plan to stop using them, but you can use them in conjunction, since command and control servers are not always mostly updated and not always containing all the tools you need in the way you need to execute them. So this can be a great way to work in conjunction. Imagine you are pulling your grant, your beacon, your agent, whatever you're using, and obfuscating it, adding a loader methods, adding bypass methods, and hosting it back to somewhere in the internet where the targeted and where you can download it on your targeted environment and use it on your day-to-day work. I also listed here references to technologies that are part of this framework. You can take a look in order to extend your knowledge, and also feel free to come out to me asking questions. I want also to thank anyone who took part in helping me with the framework, the design, the presentation itself. Thank you very much, and also thank you for staying up. I hope you enjoyed this talk. I hope to see you in Singapore sometime, maybe the next Hack in the Box. I hope you consider to adapt the CI/CD concepts into your red teams. I hope to get feedback from you about the infrastructure itself, and I will be taking on the Discord server your questions and comments on this presentation and everything else. So see you there. Bye bye.